for today's. So it is Wednesday, September 9th. We did have to switch a few things from yesterday because I wanted to make sure that you guys could do it without me. So we did switch. Instead of working through the hydrate lab, I just moved Monday and Tuesday, or Tuesday and Wednesday around a little bit. I did actually find out why people are like, where is this stuff at? Too many people are still using this. It may not be this class, but one of my classes, it was like they were using this course syllabus. Like that's got a bunch of extra stuff on there. Never use that thing for, I mean, unless you know exactly what you're looking at, like Friday, September 4th and Thursday, September 10th. I mean, that doesn't give you hardly any information of what we're actually doing. You always want to go to the actual calendar that I've created under the modules. So yesterday began stoichiometry. Hopefully that was good. I like the video on there with making the pizza or whatever, changing the recipe. That's always good. You've done the easiest part, going from moles of one substance to moles of another. If you don't know your way around the mole yet, you know, you've got to get, at some point, you've got to sit there and go, okay, I need to get this. Otherwise, whenever we start later on in the week, then it's just going to escape you. You're going to be like, wait, what? You got to know all that mole stuff from before. Luckily for you, the hydrate lab will help you out with that. So copper sulfate hydrate lab. Let's talk again about what hydrates are. And to do that, I think I should probably show you this screen instead. Gives me a little bit of blank work to discuss it on. So if you recall, hydrates are basically chemicals that absorb moisture as they sit there. So let's take barium chloride, I believe. Barium chloride. And it's a hydrate. So the formula is actually written like this. The barium chloride, for every 1 mole of barium chloride, there are so many moles of water. So many moles of water. So we've got to find that. Well, it's just like before when we did magnesium chloride. You are going to give the mass of the entire hydrate. Obviously, you'll have to do some crucible subtractions for this. And then you're going to heat it up. Well, I'm your lab partner, so I'm going to heat it up. And then you're going to have your mass of what's called the anhydride. Basically, anhydride, if hydrated has water added to it, anhydride has been relieved of that water. Then you're going to want to find the mass of water. How could we find the mass of water for that?
Are looking at the periodic table?
Nope. This is the physical mass of the water we have in the laboratory.
Couldn't
So
you
let's
just do subtraction?
Yeah, right? So let's make sure we understand. This whole thing is the hydrate. This thing is the anhydride. And this is the water. So the anhydride plus the water yields the mass of the hydrate. So if we have the mass of the hydrate and the mass of the anhydride, we subtract to find the mass of the water. So now we have the mass of both of these. But how are we going to find the mole ratio of that? Well, we change the mass to what?
Moles.
Moles. And then we divide each one by what?
Smallest.
You got it. And that should give us a 1 to something ratio. Questions there? It's pretty self-explanatory. Let me just show you the layout of the lab because it is a little bit different than we might be used to. Stop sharing. Get out of the way. Come on. There we go. So the only difference is that with this, if we take a look, here's the stuff I just did with barium chloride. Here's the procedure that you're going to see me do. And I may not reweigh it if I feel like I'm good. So if I don't reweigh it, then don't worry about it. You don't need that mass in grams after the second heating. So the empty crucible and a hydrate after the first heating. So that's the basic data table. From this, you're obviously going to have to subtract the mass of the crucible. Then it says show all your work, how each number was obtained clearly, correct units, factor label, and significant figures where applicable. Show your calculations for the mass of the hydrate before heating. Well, again, if this is the hydrate and this is the empty crucible and this is the crucible and hydrate, that math you're actually going to do right here. You're going to do the subtraction there. Mass of the anhydride, mass of the water that was removed. All those masses that I just talked about, you may want to make, you know, that data table I showed you right there on the separate sheet of paper. You may want to make it right down here. Afterwards, it says, convert the masses to moles. Then determine the simplest integer ratio of the two. And again, as Davis said, the way we do that is we divide by the smallest number of moles. Questions there? So I've taken a laboratory that takes 55 minutes probably, or 50 minutes for you to do. And then you would actually do the math part at home that night. I've taken that and condensed it into 4 minutes and 30 seconds, allowing you to get all the data you need and fulfill the calculations before the end of the day today. I know you're probably sitting there, oh, I wanted to talk about stoichiometry and the mole today. I just couldn't wait to talk about that stuff. But don't worry, we will definitely get into that tomorrow. Dang it. As you can see, I did have to flip those days just because I didn't want you guys to walk into this hydrate lab without remembering what a hydrate was. So we will definitely discuss the problems from Tuesday on Thursday. And then we'll discuss what's called a limiting reagent. And then we'll have you guys bust out into more problems with limiting reagent. Again, usually we do limiting reagent and percent yield on the same day. I've cut it down to 2 days, so that's giving you more time than normally we would have in class to work through those. So we're working at a slightly slower pace. If you have questions, by all means, stick around. I am going to end the Zoom here, so there will be private questions if you have them after everybody else leaves. Boom. There we go. Break off and work on the hydrate lab, or stick around and ask questions that you may have. If you do want to see this data table again, I will put that up there. This is the thing I made. If you want to do a screen capture of that, that can help you quite a bit for the laboratory.
Okay, I'm a little bit confused about how you would find how many moles of water. Does that just be given to you, or?
No, you have mass. So how do you get from mass to moles?
By multiplying like moles on top and then mass on the bottom.
You got it. And where does that mass from on the bottom come from?
That would be the mass of the anhydride, correct?
No, unless you said something whenever you cut out that I couldn't understand. If you have the mass of the water in the lab, then how do you change that to moles of water? You have 1 mole on top, and where does your mass for grams on bottom come from?
The periodic table.
There we go. Maybe you did cut out the periodic table of elements. Yep.
So you would do BaCl times 1 mole over however many grams or whatever the mass of water is on the bottom.
You cut out quite a bit there. You want to try it again?
So would you do BaCl times 1 mole over the mass of water?
No, because this is grams of BaCl2, right? What has to go on bottom of this then?
Oh, the mass of BaCl2.
Yeah. So that's how you would find the moles of BaCl2. You would do the same thing for the water, except for instead of having BaCl2, you would have the mass of the what?
Water.
Yep.
H2O. So that's how you would find how many moles of water?
I'm sorry, you cut out again.
Okay, I'm still a little bit confused.
You want to type it out? What your question is? I can open the chat. Are you sure? Just remember, Emma, you're not using BaCl2 in the laboratory. You're actually using copper 2 sulfate. This was just an example. So the hydrate in the lab will be copper 2 sulfate times a certain amount of water. Question, Talia?
Yes, I'm just making sure. So with the mass on the bottom, we would take 2 hydrogens, like if we're finding are the moles of H2O, we would take 2 hydrogens and add that to oxygen and then put that as the mass on the bottom.
So we'd take the 2 hydrogens, 2 times 1.01, and we would add that to the oxygen, which is 16.00. And that would be the mass of 1 mole. That's why we call this the molar mass.
Okay, thank you.
All right, I'm gonna go grab my thing and grade some real quick. Emma, are you sure you're good? Are you just ticking out in case you have a question? Cool.
Yeah, I'm good. Thank you, Mr. Jackson.
You're welcome.
Oh, yeah, Mr. Jackson.
Yeah.
I forgot to say, so the last lab we did, I submitted it
Yeah.
in the wrong, I submitted it on this lab. So I resubmitted on the correct one, but do I still just submit this one on that one? Like, will it go away, the previous one that I submitted?
Anytime you do a resubmission, it deletes the oldest one. Or so all I have is your newest one. Did you resubmit the lab it should have been?
Yeah.
Yep. And then all you got to do is submit this one onto this.
Okay, thank you.
Sounds like you're ahead today. Good.